This is another video tutorial, and I'll be going over a gas laws example calculation. The calculation that I'm going to go over is one of them actually from the homework packet. It's on page 4 of your homework packet, question number 6. It says a weather balloon is filled with helium at 23 degrees Celsius to a pressure of 0.993 atmospheres and a volume of 1 liter. What will be the temperature of the balloon in Celsius when the pressure is 305 torr and the volume is 0.5 liters? So we have a lot of variables in this particular problem. The first three numbers that were given are the initial conditions. So we have T1, pressure 1, and volume 1. What will be the temperature? That means that I'm looking for second temperature. And my second pressure is here, and my second volume. So the first thing that's always important to do is to convert your temperature. My second temperature is what I'm looking for. Now looking at the units in this problem, the volumes are both given in liters, so that's okay. But notice how the pressure is given in two different units. They have to be the same unit. They either both have to be atmospheres or both torr. So you need to change one of them. It really doesn't matter whether you change this to torr or this to atmospheres, but they have to be in the same unit. So I will change the one in torr to atmospheres. I have torr, so I put torr in the denominator, atmospheres goes in the numerator, and that's how many atmospheres I have. This requires the combined gas law formula because I have all three variables as part of the problem. And the variable that I'm trying to solve for is the second temperature. Well, just so I can work this out really slowly for you mathematically, I'm going to put down an additional piece of paper so we have plenty of space. So I'm trying to get temperature by itself. The first thing that you should do is cross multiply, right? That's when you cross over and multiply each of the variables together. So I have T2 times those over there. And that's equal to these being multiplied together. I still don't have T2 by itself, so I would need to divide by the variables that are next to it. That means I divide the other side by the same thing. And I've done that so that these variables cancel out. And the formula I end up with is T2 equals T1 P2 V2 over P1 V1. And then you substitute in the numbers that you've already put in the correct units. of my second volume, second pressure, second volume, initial temperature, divided by my initial pressure and my initial volume. And when you multiply those across the top and divide by what's on the bottom, you would end up with 59.8 Kelvin. And then converting that to Celsius, that would be minus 213 degrees Celsius. You'll see the answer on the problem is minus 212 degrees Celsius. That has to do with whether, depending what pressure unit you converted and how many significant digits you carried earlier, but either one of these would be close enough to be acceptable. So there's a tutorial video to help you be able to do the homework problem on page 4 of your homework packet.
Teachers, pardon this interruption. If you could go ahead and send the high school concert